In this video, we're going to practice verifying some identities. In the following examples, you'll notice that the powers of trigonometric functions are rewritten as more complicated sums of products of trigonometric functions. This is a common procedure used in calculus. In this first example, we have the tangent of the fourth power of x equals the tangent squared of x times the secant squared of x minus the tangent squared of x. Since this side is a little more complex, we'll be manipulating our right-hand side to try and get our tangent to the fourth power of x. So the first thing we're going to see is if we look at this term and this term, we notice that they each have a tangent squared of x. So we're going to factor that out. So here we're going to take the tangent squared of x out, and that's going to leave us with a secant squared of x minus 1. Notice that from here, this is a tangent squared of x. Now, how do we know that? We know that because it's a Pythagorean identity. And so now we have the tangent squared of x times the tangent squared of x, which is really just the tangent to the fourth power of x. And if we take a look at that, we see that that in fact matches, and so we're finished. Let's try another problem. Here we have the sine to the third power of x times the cosine to the fourth power of x equals the cosine to the fourth power of x minus the cosine to the sixth power of x times the sine of x. Again, our right side is a little bit more complicated than our left side, so we're going to manipulate our right side to get our left side. So again, what we're going to see here is that both this cosine term and this cosine term have at least a fourth power. So we're going to factor out a cosine to the fourth power of x, which is going to give us a 1 minus a cosine squared of x times the sine of x. Now, using the Pythagorean identity, sine squared of x plus cosine squared of x equals 1, we can manipulate that in a way so that if we subtract the cosine squared of x from both sides, we'll see that the sine squared of x equals 1 minus our cosine squared of x. So we can plug our sine squared of x into this spot. So now we have the cosine to the fourth power of x times the sine squared of x times the sine of x. We can then combine our sine squared of x and our sine of x, which will give us a cosine to the fourth power of x. And again, if we multiply those together, that will give us a sine to the third power of x, which is what we're looking for. We just have it written in a different way, which is not a problem because 2 times 3 is the same as 3 times 2 using our commutative property. So we can just rewrite this as a sine cube of x times a cosine fourth of x. And now we see that we match and we verified our identity. Let's take a look at another problem. In our final example, we have that the cosecant to the fourth power of x times the cotangent of x equals the cosecant squared of x times the cotangent x plus the cotangent cubed of x. So this side is a little more busy, so we're going to manipulate our right-hand side to equal our left-hand side here. So what do we notice? Well, we see that right here, each of those have a cotangent we can factor out. So we're going to have a cosecant squared of x, and now we're going to factor out a cotangent of x, which is going to leave us with a 1 plus a cotangent squared of x. Then, using our Pythagorean identity, we see that 1 plus the cotangent squared of x actually equals the cosecant squared of x. So we can plug that in. So cosecant squared of x. So what we have is the cosecant squared of x times the cotangent of x times the cosecant squared of x. Now, we'll combine our like terms. So we can multiply those out, and we're going to cosecant to the 4th power of x times our cotangent of x. And if we check and see, we see that we have matched our inequality or our identity, and we've now verified it. And we're finished.